Quadratics, page 2. So first I chose these two problems from number 3, sections B, or problem 3B and 3F. So these are similar to ones you've done before, with the strategy being, hey, let's put everything on the left, and then on the right we'll just have 0 remaining, and then we can use the null factor law to figure out what x's cause this to be 0. So for B, it looks like it's all solved, right? Hey, it's already factored, so isn't the answer -2 and 1? Oops, the right side doesn't have a 0. So no, it's not already. And how do you make it so that the right side is 0? Well, you would add 4 to both sides, right? And then this would be 0, and then this would just be kind of a mess. It would be x plus 2, 1 minus x plus 4, and that doesn't help at all. It doesn't help that these are factored because you have this left over. Okay, so now what we got to do is we got to go back and we need to make this into a polynomial again. Oh, so we need to multiply it out. So let's see. We use FOIL. Okay, and we'll say x times 1 is x, 2 times -x is -2x. Then we do the inside terms, and we do the outside terms. The inside terms, 1 times 2 is 2. The outside terms, -x times x is x squared, -x squared, and then we have our plus 4, which we brought from the other side. Now we need to rearrange it so that the squared is on the left, and then we combine these two and we get -x, and then we combine this and this and we get plus 6. Okay, and if you don't like working with a -x squared, that's not what we're used to, you can just multiply everything by -1, because this is 0, so even if you make that negative, it doesn't change. So now we'll have x squared plus x minus 6. We're going to switch all the signs because of this negative here. Now we can factor. With 6 on this term here, it would be either 1, 2, 3, or 6 as far as the factors, right? Since we know that what we want to get here is x, probably it's going to be the 2, 3 that we use, because 3 minus 2 is 1, so that kind of makes it look like that's going to be the answer. So we're going to put minus for both and see what happens. -2 times -3 is positive. Oops, we need to make one of these negative and one of them is positive. So let's make this negative and this positive. -2x plus 3x is 1x. Hey, that's right. So we guessed right. If we had chosen plus minus plus here and minus here, that would have been wrong, and we would have had to guess again. Okay? So now x minus 2 equals 0. X plus 3 equals 0. So when x minus 2 equals 0, that's actually the same as x equals 2. When x minus 3 equals 0, that's actually the same as x equals -3. So these are our two solutions. Okay. Now let's do f. This one looks kind of a mess, but it's not so bad. With algebra, we need to put everything in the numerator on top. So for this left side, we should multiply by the denominator for both sides. So we'll multiply the left side by 1 minus x, and we'll also multiply the right side by 1 minus x, because you can't multiply just one side by something. You have to multiply both sides by the same thing, because that's the rule with algebra. Whatever you do to the left side, you have to do to the right side too. That will maintain the equality. So now we can cross these out because they cancel out. 1 minus x divided by 1 minus x is equal to 1. So we're left with x plus 3 on the left side. On the right side, we still have something in the denominator, which is x. So how do we get rid of that? We're going to have to multiply both sides by x, because that's what you do in algebra. You have to multiply both sides by the same number. On this side, we got x squared plus 3x. On this side, cancel those out, leaves 1. We get -9 plus 9x. And then we're going to move everything to the left. X squared. And then we're going to do minus 9x from both sides. And that'll give us negative 6x. And then we're going to add 9 to both sides to get rid of that one. And we'll get plus 9 equals 0. Okay, so x squared minus 6x plus 9 equals 0. And we're running out of space here. So this factors into, let's see, well, 9 doesn't have too many factors, either 1, 9, or 3. We'll put 3's. And we'll just put negatives here because that's easier. We don't have to erase to make those into positives. Negative 3x minus 3x is negative 6x. Hey, we guessed right. Okay, so now we know the solution is x equals 3. And actually this other one gives us the exact same solution. So we get two solutions, but both those solutions are 3. X equals 3, so that's it for that one. Okay. Now the next section, equations of the form ax squared plus bx plus c equals 0 can be converted to the form x plus p all squared equals q, from which the solutions are easy to obtain. And they are gradually moving you to the process of completing the square, and this is one of the first steps. Okay, so they're saying, hey, if you do factor it and you have a perfect square like this one, when I say a perfect square, instead of having like x plus 1 times x plus 3, do you see how you have x plus p squared? So you have the same thing squared times itself. If you have a perfect square like that, then you can use that to go all the way to the end and solve for x, because you could just take the square root of both sides and you'd have x plus p equals square root of q, right? And then you're pretty much done. Maybe you don't know what I mean, but let's take a real example. It's easier. So our strategy here is move things that aren't in the perfect square. There's the perfect square. We're going to move the things that aren't the perfect square all to the right side. So this time we're not putting 0 on the right side. We're going to have a number on the right side. And on the left, we're going to have a perfect square. So you're already almost there here. The only thing you need to do is, we already have our perfect square. So we're going to subtract 1 from both sides. And that will leave x plus 1 squared on the left side. And then on the right side, we have 11 minus 1 is 10. And then we're very close to getting a value for x now. You can kind of see already, even if you didn't do the algebra, you can say, hey, if I have x plus 1 squared, it's going to give me 10, so x plus 1 is going to be the square root of 10, right? So let's do that with algebra, because then you don't have to torture your brain so much. So you take the square root of both sides, because if we take the square root of both sides, you are you're doing the same thing with both sides, so the equality is maintained. Just one thing, when you take the square root of a number, remember that that number can be positive or negative, because the square root of a number, if it's negative, multiplied times itself, you lose the negative. So two negative numbers multiplied times each other give you a positive number. Two positive numbers multiplied times each other give you a positive number. So, you know, 10, the square root of 10 is about 3.16 something, but it's an irrational number which goes on forever. But let's say it's 3.16. It could be positive 3.16. It could be negative 3.16, either one. So when you write the answer to this, you write plus or minus the square root of 10, because it could be either one. It gives you two solutions. So now you have x plus 1 equals plus or minus square root of 10. Now we want x by itself on the left side, so what we do is we subtract 1 from both sides. That gives us x on the left side. And on the right side we have negative 1 plus or minus the square root of 10. And if you did it with your calculator, you would find that square root of 10 is about 3.16, so this would be, you know, basically negative 3.16 minus 1, and it would also be positive 3.16 minus 1. So one of the answers would be like 2.16 something something, and the other answer would be like negative 4.16 something something. Is that right? Negative 1, maybe? Okay, so so those are two answers, but you can leave the answer like that. Okay, so this is actually, since you have a plus or minus here, that's saying that there's two possible solutions. Okay, and I think that's it for page 2. That was 1G.